So this is going to be objective 21. We're going to kind of switch gears a little bit. We're going to go back to our unit circle, okay, which is always good to come back to it. And we're going to learn how to graph sine and cosine functions, okay, how to graph them. Okay. All right, so first thing we're going to do in order to graph is, like, we're going to make an XY table. Do you understand that? We're going to make an XY table. So what I would like for you to do, I'm going to hit pause for a second. I'm going to do the first ones for you. Then I want you to take your unit circle, and I'm going to have you fill in the rest. Okay, so if we look at our unit circle, first of all, what do we know about the sine? Where would the sine be located on our unit circle? It's the y coordinate. What's the cosine? The x coordinate. Everybody understand that? So if I look at 0, I'm at 0, which is over here. Okay? What is the sine at 0? The sine is 1. Okay, so in my chart, I'm going to put in a 1. If I go to pi over 6, are you with me so far? What is the sine? 1/2. Okay, get your chart out so you can use it, see it, know it. Okay, it's 1/2. Okay, if I go to pi over 3, okay, what would be my sine? It's going to be the square root of 3 over 2, but if I'm going to actually graph this, how many, like, don't know where square root of 3 over 2? Like, we know where 1 is on the graph, up 1, correct? Okay, we know where 1/2 is. You're up in between 0 and 1. You're at 0.5. But what's the decimal of square root of 3 over 2? What's square root of 3 divided by 2? Put it in your calculator. Square root of 3 divided by 2. 1.2? 1 point. All right, let me hit pause, which would be, so if I was actually going to graph, so we know this is equal to, I'm going to say 0.87. So where would you actually graph 0.87? Right below 1, right? Right below 1. Okay, so let's go to pi over 2. What's going to be the sine? Oh, let me just go back to this. I wasn't thinking, I was thinking cosine. What's the sine at 0? 0, I'm sorry about that. Okay, what's the sine at pi over 2? 1, okay? So you got what I'm talking about? We're just looking at the y coordinate, so I want you to take a minute and fill in the rest of this. All right, so I finished mine out. Did you get the same thing I did? Okay, yes? Any questions? Did I miss anything? Okay, so what we're going to do is we're now going to graph this. Okay, we're now going to graph this. So basically, you're going to graph it like an x and a y axis, but in this case, the sine is going to be your y-axis, and your x-axis is going to be your radians. Okay, so if I graph this and went across here, we would have 0, then pi over 6, then pi over 3, then pi over 2, then 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Okay? what's the furthest, if the sine's going to be on our y, everybody agree? Okay, this is really like y equals the sine of t. So this is our y. What's the furthest we go up on the y-axis and the furthest we go down? Like, look at your numbers here. Whoops, they erased. I don't know where they went. Did it go up to 1/2? Square root of 3 over 2. It went to 1, right? So here was 1, and this is square root of 3 over 2, and this was 1/2, and this was back down to 0. Then this was negative 1/2. Negative square root of 3 over 2. Negative 1. So that's the lowest we go, right? It's down to negative 1. So the highest we go is going to be up here at 1, and the lowest we go is down to negative 1. Okay? So if we kept going with this, negative square root of 3 over 2, negative 1/2, and then back to 0. Okay. If we plotted these, so at 0, I'm going to be at 0. Okay? If I go over to pi over 6, where's 1/2? Positive 1/2. Where would 1/2 be? In between 0 and 1, right? Halfway. Okay. Then here we said this one's going to be about 0.87, so right below 1. And then when we get here, we're going to be all the way up at 1. Okay. Then we graph back down. Here's square root of 3 over 2. Here's 1/2. And then at pi, we're back down to 0. Then we go to negative 1/2, which would be down here. Then negative square root of 3 over 2 is going to be close to negative 1. Then 3 pi over 2 is going to be down at negative 1. And then it's going to come back up. And then back to 1/2, and then back to 0. And if we connected it, it's going to look something like this. Okay? That is a sine wave. Okay? That is a sine wave. Okay? That's a basic sine wave. Okay? What can you do to graphs? Like in Algebra 2, based on what you learned, what did you do to like your functions, like a absolute value graph? What could you do to it? You could flip it. What made it flip? What made it reflect? But what happened to the equation? Do you remember? It was a negative. If I put a negative out in front, it would make it flip. Okay, what else could you do to like an absolute value graph? Well, you could rotate it, but if we translate it, most of the time you shift it up, you could shift it down, you could shift it to the left, you could shift it to the right. Remember, you could vertically stretch it, or you could vertically make it wider, like so. So during doing certain things to the equation is going to cause it, so that's what we're going to do from now. But here is your basic sine wave. And one full basic wave goes all the way to 2 pi. Why would it all the way go to 2 pi? Because if we're talking about the unit circle, what's one full rotation? 2 pi, right? That's the basic. Now, it might change from there, but the basic is going to be from 0 to 2 pi. Does that make sense? The basic, and that's because it's based off the unit circle, okay? So this is what it should look like. And notice on this one, they actually graphed the pi's over 4. Does that make sense? Allison asked me, like, why aren't you using, like, the pi's over 4, 3 pi over 4? I could have. I just picked the 30 degrees. Does that make sense? Okay, so let's look at cosine. Let's look at our most basic cosine. What do we know about cosine according to our unit circle? It's our x, okay? So I want you to take a minute in your group, go through each radian, Write down the x-coordinate. Now I want you to see if you can actually graph it and see if is it going to be the same as the sine wave, or is it going to be different? Maybe it'll be flipped. Let's see how it changed. Okay, so take a minute and see what you can. Okay, so in this case, it's going to be y equals the cosine of x, or cosine of t. It doesn't matter. So if I started this, still, what's the highest it's going to go and the lowest it's going to go? 1 to -1. Okay, and that's because that is based off the unit circle. Okay, it's not always going to be 1 and -1. We're going to change that and adapt it, but the most basic graph of sine and cosine is going to be from 1 to -1. Okay, that's the most basic. So if I graph this will be pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and then finally to 2 pi. Okay, so if you graph this one, the first one's going to be up at 1. Then it goes to square root of 3 over 2, which is the same thing as 0.9. So it's going to be right around here. Then 1/2. Then down to 0. Then down to -1/2. Then down to 0.9. Maybe I should put my 1/2 right here. And then down to -1. And then 0.9, 1/2, back to 0. And then 1/2, 0.9, and then 1. So if I connected it, it would look something like this. And don't just make it look like a V, because when it gets up here, what's going to happen to it? It's going to take a turn, and then it's going to do what? Go back down. But this is one full wave from start to finish. Notice we started at 1, we ended at 1. Does that make sense? And then it could go again. And then it could go again. So if we compare the two, that's the actual graph. That's what it should look like. Notice they used different points. They used pi over 2 and pi and 3 pi over 2. I went ahead and did all the 30s so you could actually see the actual curvature of it. But if we compare the two, sine and cosine, that's the difference in them. Okay? Notice cosines start at 1 and then go all the way down and come all the way back up. Sines are going to start at the origin. They're going to go up, they're going to go down, and then back to the origin. They start and they finish at the same place. Okay, one full wave. Any questions so far? Those are your basic graphs. So now what we're going to do is we're going to take them and we're going to shift them a little bit. We're going to flip them, we're going to shift them, we're going to squeeze them in, vertically stretch them, we're going to make them wider. Does that make sense? And change things about that. So if we graphed this one, what if I took like the first, and you don't have to make a chart every single time, okay? You can kind of just use, and you don't have to use all those different points, like if you just want to kind of sketch it. We know if it's cosine, first of all, and I start here at 0, but then what am I going to do to it? I'm going to add 2 to it. So normally cosine is going to be where? Where's the cosine at 0? It's at 1, but then if I add 2 to it, where will it start? 3. Okay, so actually this one's going to go all the way up to 3. Okay, if I look at, give me another one around here. Maybe we should do the pi's over 4 this time, just to do something different. Okay, what's actually square root of 2 over 2? Somebody divide square root of 2 divided by 2. 0.7. Okay, so, but then I'm going to add 2 to it, right? So what would it be? So here at pi over 4, it's going to be like 2.7. Does that make sense? Let's go to pi over 2. Okay, what's the cosine at pi over 2? 0. So if I add 2 to it, what's it going to do? It's going to be at 2. Okay, and then if I keep on going around, let's go to 3 pi over 4. Not 3 pi over 2, 3 pi over 4. It's negative square root of 2 over 2. Everybody agree? Negative square root of 2 over 2. So that's negative 0.7. What's negative 0.7 plus 2? Negative 0.7 plus 2. 1.7. Okay, so it's going to be, here's 1, here's 2, here's 3. So 1.7 is going to be somewhere around here. Okay, and then we get all the way over here to pi. So it's negative 1 plus 2 is going to be 1. And then I'm going to keep on going up. So this is 5 pi over 4. Then 3 pi over 2. Then 7 pi over 4. And then 1 full rotation is 2 pi. Okay. So then this is going to just come back up from here at the same spots. Here, and then here, and then here. So if I graph it, it's going to come down like this, and then it's going to come up like that. It needs to be, make sure it's curved. And again, we're just sketching. But it's going to look something like that, okay? If I graphed it normally, like the normal one, and compared it, the normal one that we just graphed a minute ago went from 1 to negative 1, agreed? So everything was just what? Shifted. It's shifted pi over 2, that's 0.7, or this is 0.7. So it's going to go, let me see. Come on, Miss Corns. Yep. Okay, so negative 0.7, so roughly around 1.3. Okay, I'm trusting y'all with your calculators, and I'm just going with your numbers. This one goes like this. And then it should come up back to 1 like that. So let's compare the graphs. What happens when you add 2 in front of it? Here's what I want to get at. What happens when you add 2 to it? It shifts it up, okay? And that should be, this should be a review. Like in Algebra 2, I might have given you y equals the absolute value, gosh, struggling this morning, absolute value of x plus 2. Well, we know the parent function is a v. This is what you learned in Algebra 2, right? So if I add 2 to something, what happens to it? It shifts it up 2. Okay, doesn't make it, doesn't change, you know, how big it is. The whole thing just shifts up 2. Okay, the whole thing just shifts up 2. Okay, any questions on that? So it's the same graph, it's just going to shift up 2. Okay, let's look at it when I stick a negative in front of it. What do you think is going to happen? It's going to take it and flip it. So you do it. Okay, take the basic and times it by negative 1 and get your new point. And you can use it, just pick some points around here. Okay, I definitely would pick like your 0, your pi over 2, your pi, and your 3 pi over 2. But in between there, just pick a couple random points to plot. Okay? I would make sure that, like, if you're going to count by 30 degrees, like the first time we did it by 30 degrees, correct? We started with 30 degrees, and we counted by 30 degrees all the way throughout. Do you understand that? The second time we did it just a minute ago, what did I count by? I did by 45s. Does that make sense? So, like, you need to decide the in-between ones. Like, if you're going to count by, and it's like that with any graph. Like, when you draw a bar graph, you know, if you're going to count by 2s when you graph, you don't count by 2 here, and then 7 here, and then 12 there. Do you understand? Because that makes your graph change. If you're going to start out by counting by 2s, you got to count by 2s the whole way up. Okay? If you're going to start out counting by 30 degrees, you got to count by 30 degrees the whole way. If you're going to count by 45s, count by 45s the whole way. Does that make sense? Like this. So if I graph the original cosine of x, we know that it's going to go like this. Okay? Every single time. That's the original. Okay? If I times it by a negative, so if the first one is 1, if I graph, so this one is y equals cosine of x. I'm going to graph the second one red. Okay? If I times that by -1, if I graph y equals the negative cosine of x, where's your first point? -1. Everybody agree? 1 times -1 would be -1. Okay? What about the second one is 0? What's negative times 0? It's still 0. And then the third one was -1, so now it's going to be +1. And you go back like so. And it goes up, and then it goes down. Okay? Again, try to not make it look like a V. Make sure it looks like a curve. Okay? And then you can put in, for time purposes, like if you were going to really graph it nicely, I would encourage doing the 45s. That might be the easiest one to do. Instead of the 30s is going to be more points, okay, around. But definitely make sure you have your 90s, okay? Any questions on that? So if there's a negative in front of, if I'm adding something to it, it's going to shift it up. What if I subtract something to it? It's going to shift it down. It's going to take the same one and just completely shift it up, okay? If I put a negative in front of it, it's going to take it and it's going to flip it, okay? So let's talk about our amplitude, okay? Amplitude is the largest value the function attains, meaning, you might want to say on here, in plain English, the height. Okay, the height of it. The basic, what's the amplitude of a basic problem? How far up? 1. Okay, so it's got an amplitude of 1. Does that make sense? 1 up, 1 down. That's your amplitude. Okay. A minute ago when we added 2 to it, well, it still had an amplitude of 1 because that was the basic, but then you added 2 to it, which shifted it up. Okay. But the amplitude's going to be the number in front of the sine or the cosine. Okay, whatever's in front of it. But it's got to be the absolute value of it. Like a minute ago, there was a negative. A minute ago, we had the negative cosine of x. Okay, so does that mean your amplitude is -1? It's got to be the absolute value of it. Okay, so this has to be the absolute value of A. Okay, so really, what's the absolute value of -1? 1. So it still has an amplitude, 1 up, 1 down. Okay, so what if I put a 3 in front of it, a -3? The amplitude is going to be 3, meaning if I graph this, how far up am I going this time? 3, and how far down? To -3. Does that make sense? Instead of going up to 1 and down to a -1, it now becomes you're going up to 3. Okay? And basically to figure out your points, you just multiply it by -3. Okay, so this one's going to be, what do you know about the shape of this one? Is it going to be a U, because a curved U, or is it going to be an N? What's the basic? The basic is a U. It goes down and then it comes back up. Yes? Okay. Now we know this one's going to start down. Instead of starting up, it's going to start down and it's going to go up and go back down. So it's going to be more like a shape of an N. Okay? And if I graphed it, I'm just going to graph the 90s because I think that'll be easy. So this will be pi over 2. This will be pi. This will be 3 pi over 2. And this is going to be 2 pi. So far, so good? So we know now that I'm going to go from here. What's -3? We know at pi over 2 it's 0, right? So is it still going to be 0? At pi over 2, the cosine is 0. What's -3 times 0? 0. It's still going to be 0. And this one's going to go all the way up to 3, and then here, and then here. So it's going to look like this, and like this. And again, extend it on up so it doesn't look like it comes down like this. Okay, I probably will take points off if you draw a sine wave or a cosine wave and you draw it like straight down, because it's not going to go down. The furthest it's going down is -3. Okay? Any questions about that? So the number in front, it's the absolute value of it. That gives you your height. That gives you your height on it. Okay? We're almost finished. So let's talk about sine and cosine waves have an amplitude of the absolute value of A. It has a period of 2 pi over k. K going to be located in front of the it's going to be the number in front of the x. The A is going to be the number in front of the function. Okay? The k is going to be the number in front of the x. So what did I tell you? A period to me says one complete wave. I can make one complete wave. On a basic sine or cosine, one complete wave is how much? And that's what this says down here. An appropriate interval for one complete period or one complete wave. Do you understand that? Start to finish, one complete wave. That's your period. Okay? Generally is 0, 2 pi over k. From 0 to 2 pi over k. Okay? Let's look at the basic. Like y equals sine of x. So what number's in front? 1. That meant it went up to 1 and down to 1. Do you understand that? Okay. What number's in front of the x? A 1. So here's your k. What's 2 pi divided by 1? That's why it was one complete wave was from 0 to 2 pi on the basic. Does that make sense? So we may change, that's the basic, from 0 to 2 pi. We may change and kind of, basically I look at it like an accordion. Does that make sense? Like a normal wave starts from 0 to 2 pi. What if I take it and I compress it and I do one complete wave before I get to pi? Does that make sense? That means I've changed my period. Okay, one complete wave. Do you need more time on this? Yes? Okay. Let's take a look at example 4. Okay. These numbers mean something. Let's talk about, first of all, what the basic looks like, because I want you to refer it back to the basic. Okay. So the basic function, if I graphed it, maybe I should graph it over here. We know the basic y equals cosine of x goes up to 1 and down to 1, right? And then if I said this was pi and this is 2 pi, so this is pi over 2 and this is 3 pi over 2, we know it's going to look like this. So it's going to go here to here, to here, to here, and back up. So, and if I curved it, it's going to look like this. That's a basic cosine function. I would highly encourage you memorize that. Okay, and if you can't memorize it, have your unit circle handy and plot your points and look at what the cosine is. We know the cosine is the x-coordinate. Okay, but let's see what happens to this wave. First of all, when I multiply it by 4 in the front, that 4 is going to mean something. And it's not just the cosine of x, it's the cosine of 3x. So those numbers, 4 and 3, are going to change this shape a little bit. Okay, does that make sense? My question to you is this. Is it going to shift it up or down? Well, what would shift it up if I did what to it? If I added or subtracted something to it. Am I adding or subtracting anything to that? Then it is not shifting up or down. Is this going to reflect it? What makes it reflect? A negative. Does it have a negative in front? No. So I'm taking this actual function and we're going to do something else to it. Okay? We're going to stretch it, okay, or compress it. Okay? So let's first talk about the 4. What is the 4? Is it our amplitude or is it our period? It's our amplitude. So the 4 is our amplitude. And I gave you in your notes, I said an easier word than amplitude, because right now I'm going to say, what's amplitude? And y'all are going to go, I don't know. But what did I say? It's your height. We know that this is going to, instead of going up to 1, does that make sense? It's now going to go up to 2, 3, 4. And then it's going to go down to 2, 3, 4, negative 4. Okay? So it's going to go up to 4 and it's going to go down to negative 4. Okay? Any questions on that? Okay? Let's talk about the period. The period is the room for one complete wave. Normally, one complete wave goes from 0 to 2 pi. So based on, if I go back one slide, what does it say to do to this number right here to figure out the period? I'm going to take 2 pi and divide it by k. So I'm going to do one complete wave. In this case, my period, go back. My period is what? 2 pi over 3. Okay, you always take that number and take 2 pi and divide it by that number. So that means, where's 2 pi over 3 at on our unit circle? Where's 2 pi over 3? So look right here. Everybody look. Normally you do one complete wave, one complete from 0 all the way to 2 pi. We are now going to do one complete wave from 0 to 2 pi over 3. Now, here's where it gets a little tricky. You've got to take 2 pi over 3, and you've got to, remember how I said you got to count by the same thing all the way across? So if this is 120 degrees, what do you think we should count by? Maybe 30s. So let's do pi over 6. Let's do pi over 3. Let's do 2 pi over 3, correct? Does everybody understand that? And so what's going to happen is it's going to do one complete wave from 0 to 2 pi over 3. So you can plug it in and times it if you want to. Does that make sense? But I know based on my normal, like if it's going to do one complete wave, first of all, where are we going to start at? I'm going to start up here at 4, okay? Where are we going to end at by 2 pi over 3? Where does it end? It starts, one complete wave will start and finish at the Same spot. So I know at 2 pi over 3, it's got to finish here. Okay? I know at pi over 3, and you can split it up like evenly if you want to. So halfway between 120, did I forget my 90? Thank you. I'm sorry. I'm going to scoot it over. So this is pi over 2, and this is going to be 2 pi over 3. So that's still going to end up at 4, okay? I know as it's going down that this one's going to be at where? 0, and then -4, and then back up to 0, and it's going to go like so. And it's going to curve on down. Okay? So what I have done, if you compare it to the original, first of all, I have vertically stretched it up because I have increased the amplitude, and I have also taken it, and where it was doing one full complete wave from here to here, it is now doing what? I took it like an accordion and I squashed it. Okay? Do you understand why I counted by 30 degrees? I looked at my period, like what if my period comes out to be, I don't know, 4 pi? What might you count by? How much is 4 pi? Like you could count by halves. Does that make sense? All the way around twice. Or you could count by pi, 2 pi, 3 pi, 4 pi. Does that make sense? You could count that way. But however you're going to count, it's got to be the same increments. You got to count. If you're going to count by 30 degrees in the beginning, you got to count by 30 degrees the whole way through. Okay? Whatever you do. Okay? Let's do one more just to introduce it to you. Aaron has a question. Yep. So I first want you, this is our last problem for today. Okay? I first want you to graph the basic sine. Okay? Go back to your notes. Graph, like just sketch the basic sine one. Okay? Let's talk about what we know is going to happen to the height of it. What do we know the negative is going to do to it? And what do we know the 1/2 is going to do for it? Okay? So if we look at our basic function of sine, sine's different than cosine, so I want to make sure you remember. We did a bunch of examples on cosine. Sine starts at 0. If I just did a couple key points, so if I did pi over 2, pi, 3 pi over 2, and 2 pi, right? That's your basic. Where's it going to go? And this goes up to 1 and down to -1. Okay? This is going to go up to 1, then where? 0, then where? -1, then 0. And it's going to go like so. Okay? And that's one full start to finish. It goes up, it goes down, then back here. And then it would start all over again. It's going to go up, down, back to 0. Up, down, back to 0. Where do you think in real life? Like I know some of you are thinking, this is like beyond what I can grasp. But where in real life would you use sine waves? Radio station, radio waves. Does that make sense? That's what they are. They are sine waves. Does that make sense? If you're interested in, develop anything with music, those are all sine waves. I'm with you. Like a heart monitor. I'm not sure. I don't think it's exactly like a sine wave. Does that make sense? But it does. It kind of goes up and goes down like so. But you know, most popular, I would say radio stations. You know, radio waves, music waves, things like that. Okay? Microwaves. Okay. So here we go. Let's just kind of maybe make a list, okay? We know our amplitude is going to be what for this problem? 2. Okay, that means instead of going up to 1, I'm now going up to 2. And I'm going to go down to -2. Okay? We know that our period, the length for one complete wave, normally it's 0 to 2 pi to do one complete wave. Okay? How are we going to get the period? We take what? 2 pi and divide it by what? 1/2. What do you get? Let's try this. 2 pi is what? Is a fraction. Okay, divided by. So what can I do? What is it? It's 4 pi. 2 pi times 2 is 4 pi. And 1 over 1 is 1. And 4 pi divided by 1 is 4 pi. So what am I doing this time? Like, am I, like, expanding it or compressing it? If I'm going to do one complete wave, normally I do one complete wave from 0 to 2 pi. But this time I'm going to do one complete wave from 0 to 4 pi. So what's happening to my little wave? I'm stretching it out. Does that make sense? It's going to get fatter. So again, we know we want to go, here's how I decide what I count by. I know I've got to start at 0. You follow me? And we know the first point, if the basic is at 0, where's the first point here going to be? At 0. Okay. And I know I want to go all the way to 4 pi. Correct? So I'm going to split this in 4 equal parts, or actually 5 equal parts. 1, 2, 3, 4 equal parts. So halfway would be where? What's half of 4 pi? 2 pi. And then half of that is pi, and then half of that is 3 pi. And that's equal increments. 1 pi, 2 pi, 3 pi, 4 pi. Okay? So if I use my basic to mimic what I'm doing, where am I going to be at pi? I'm going to be up at 2. Where am I going to be at 2 pi? At 0. Where am I going to be at 3 pi? -2. Where am I going to be at 4 pi? 0. Oh, it is. Thank you. So what should I do? These are all still going to be 0, so where will it be? It'll be -2, and then up here to 2, because I'm flipping it as well. So it goes down. Instead of going up, it's now going to go down. Thank you. Okay. Any better? That one was easier? Okay. So I'm going to stop there for right now.